Hooray! So we're gonna shift our sine and cosine again, but this time we're gonna change the period. So the part where I ask you to find the period is now going to become even more important because it's not just going to be 2 pi this time. Right. All right, so I'm still going to ask the same questions. For those of you who are maybe struggling with this a little bit, I would write amplitude and then write what the amplitude is, and maybe where you found it. Then write period, so you know I'm doing this work to find the period, and then show all your work. So the amplitude, the number in front of cosine, is 1/4. And we'll break a little bit of the rules and call it -1/4, because that's going to tell us what to multiply by when we're finding our y values. I'm a rule breaker. Does that take it up? Huh?
Does she not like that?
The period is 2 pi over b. B is the number in front of x, so it's 2 pi divided by 1/2. Which is 4 pi. Yeah, so you would flip the 1/2 and multiply 2 pi times 2 and get 4. So we'll find out where to start and find out where to end, very similarly to how we did the last time. So we'll set up our inequality. It's going to be, we're going to have to do 2 steps. So I start, like I did last time, by subtracting pi over 2 from both sides. So 0 minus pi over 2 gives us negative pi over 2. 2 pi minus pi over 2 gives us 3 pi over 2. Oh, sorry. Little mistake. 2 pi is the same as 4 pi over 2. 2 pi is the same as 4 pi over 2. And then I subtract 1 pi over 2 from 4 pi over 2 and get 3 pi over 2. To handle the 1/2, I multiply everything by 2. So negative pi over 2 multiplied by 2 gives me negative pi. 3 pi over 2 multiplied by 2 gives me 3 pi. So that means I would start graphing my 1 period worth of cosine at negative pi, and I would end graphing my 1 period of cosine at 3 pi. The period is 4 pi, and the distance between negative pi and 3 pi is 4 pi. To get rid of the 1 attached to the x. Not whatever. I'm going to try and make it smaller. Okay, so we got our amplitude, breaking the rules. We got the period. We know where to start and end our 1 period. Now we want to know how much, starting at negative pi, how much we should add to know where our points will be. So I'll take the period and divide by 4. So we're still dividing by 4. 4 equal intervals. That gives us pi. So starting at negative pi, to get to the next point, we add pi. That'll be our next x value. Then we'll add pi until we get to 3 pi. I like pi. I'm good with it being pi because its denominator is 1. The denominators for negative pi and 3 pi are both 1. So it's nice and easy to be able to add pi to those things. So now I can set up my table and then graph it. Because I'm breaking it into 4 intervals. Just like we always are. To find out the interval, we'll always divide it. So I'm just adding pi. I get 0, pi, 2 pi, 3 pi. If you can graph without the chart, that's fine with me. I always like a way to organize my thoughts. For cosine, my first y value is 1 for regular cosine. So I'll multiply it by negative 1/4. Then I go to 0, 1/4, 0, negative 1/4. Let's do one more together. So I'll start by finding my amplitude again. It's number in front of sine. This time we don't have to cheat. It's just 2. Period's 2 pi over b, and b this time is 3, the number in front of x. So we'll complete one curve from 2 pi over 3, distance. Minus 2 pi over 5. So now we have to add pi over 5, and then we'll divide by 3.
Where do you get that 3 from? Oh.
So I'll add pi over 5. And then I'll divide everything by 3. Yeah. So when I divide by 3, it's the same as multiplying by 1/3. So I'm just multiplying the 3 and the 5. So I start at pi over 15, end at 11 pi over 15. And that distance is 2 pi over 3, because 2 pi over 3 is the same as 10 pi over 15. It's ugly, but it works. So now I need to know what to add to pi over 15. I'm going to take my period and divide it by 4.
So 1 pi over 6.
Yeah.
Oh, that's terrible.
This is awful. If you can get through this one, good. So I want to have a common denominator with 6 and 15.
30.
So I know what to add. Yeah. So I want this in 30ths. It's a little bit ugly. Pi over 6 in 30ths is 5 pi over 30. Just multiply the top and bottom by 5. It is. So even though it looks ugly, the process is the same and it works. Where are you stuck?
You got 5 over 30.
So I want the 6 and the 15 to have a common denominator, and the least common denominator is 30. To multiply by 6 to get to 30 is I multiply by 5. So I multiply the top and the bottom by 5. 5 pi over 30 is the same as pi over 6. Okay. Pi over 15 is the same as 2 pi over 30.
No, can we actually do a benchmark on this one? I did terrible.
Probably on the test, I won't do fifths.
Probably, or
No, I definitely won't. I'm not interested in testing you on your dealing with fractions. But
We have a quiz on this next week.
that's right.
Tuesday. Monday.
Tuesday
Tuesday, like
Last
tomorrow?
thing we're learning, last section.
for the quiz. Yeah.
Tuesday elections.
No, there's one more thing I have to add. In comparison to this, it's easy. So I'm starting at pi over 15, ending at 11 pi over 15, and I'm going to go up by 5 pi over 30.
Why is the first one pi over 15? Wouldn't it be 2 pi over 30?
You could. I don't care what you do it. If you want to write it in 30ths, that's fine. So when I add, the reason I changed this to 2 pi over 30, so when I add 5 pi over 30, I have 7 pi over 30. Then I add 5 more and get 12 pi over 30. And then I add 5 more and I get 17 pi over 30. And then I add 5 more and I get 22 pi over 30, which is the same as 11 pi over 15. Maybe I'll just make this one the test. Or
Pi over 15 is 7 pi over 30.
right, because this is the same as 2 pi over 30. Okay, so we're dealing with sine. Sine starts at 0, goes to 1, then to 0, then negative 1, then 0. My amplitude is 2, so I multiply them all by 2.
And I feel like Hug's bodies are kind of now look at that body so skinny, he's like a skinny with the wrong color. Dude, I told you someone brought my dog to my door saying I need to come here. I was like, you don't understand my dog.
Yeah. Try this. Okay, so amplitude. 2, the number in front of cosine is 3. The period is 2 pi over b. In this case, b is 1/3. That's from the 1/3 x. So 2 pi divided by 1/3 is 6 pi. So that means from the start to the end of one curve, it's going to be 6 pi in between. To get my start and end points, I first add pi over 3 to 2 pi and 0. And then I multiply each of those by 3. So pi over 3 times 3 is pi. 7 pi over 3 times 3 is 7 pi. So I start at pi and end at 7 pi, and I'll have one curve with a period of 6 pi. To figure out what to add to my interval width, I divide the period by 4. That simplifies to 3 pi over 2. So every 3 pi over 2 is where I'm going to have one of my points. Pi is 2 pi over 2, so starting adding here, 2 pi over 2 plus 3 pi over 2 gives us 5. Then we can just roll. 8 pi over 2, 11 pi over 2, 14 pi over 2, which is 7 pi. So each of my units is pi. In between them is pi over 2. So that's why I have some points in between my hash marks. Questions?
So instead of like for the start and end points is always going to be 2 pi.
We're taking the original period, and then these two things are going to manipulate it for us to figure out where we're going to start and where we're going to end. All right. So I want you to try those 4. I'll collect them at the end.
Just trying to small.
What?
Practice. Practice.